Section 7.4 is on addition and subtraction of rational expressions. So this shouldn't come as a big shock given that we just learned about least common denominators. Oops, addition and subtraction of rational expressions. We notice that we can only add or subtract rational expressions with common denominators. So if we had x divided by x plus 1 plus 3 divided by x plus 1, we have a common denominator, and so that's x plus 3 divided by x plus 1. We also want to pay attention to whether or not we can simplify after we've done the addition or subtraction. So if we had x squared divided by x plus 1 plus 2x plus 1 divided by x plus 1, we notice that would be x squared plus 2x plus 1, all divided by x plus 1. And so we notice that now we can write that as x plus 1 divided by x plus 1 gives us x plus 1 as long as x isn't negative 1. And so you're not going to come across that often, but it's worth noting that once we've done our addition or subtraction, we want to verify that there isn't any simplification that can be done. So we check to see if there are any common factors in the numerator or denominator. And this works for subtraction as well. If we had x plus 2 divided by x squared minus 3, I'll make it x squared minus 4. Minus 4 divided by x squared minus 4. We notice we're going to get x plus 2 minus 4 divided by x squared minus 4. That gives us x minus 2 divided by x squared minus 4. And we notice that x squared minus 4 factors as x minus 2, x plus 2. And you notice we might have factored that in process as we were going through some of the earlier steps. And so we notice we're going to get 1 divided by x plus 2. We notice that x minus 2 we could write as x minus 2 times 1. So the x minus 2's go away. We're left with 1 divided by x plus 2 as long as x isn't 2. Because x equals 2 would give us 0 divided by 0. So unsurprisingly, where life gets a little more complicated is if we don't have a common denominator. If we want to add or subtract the rational expressions anyway, we have to rewrite them as equivalent to rational expressions that have the least common denominator. So if we had 1 divided by x plus 1 divided by x plus 1, we have to first notice the least common denominator is x times the quantity x plus 1. So we write it as x plus 1 divided by x plus 1 plus x divided by x plus 1. And so we notice that we then get x plus 1 plus x, all divided by x times the quantity x plus 1, which gives us 2x plus 1 divided by x plus 1. And we kind of leave it that way. We can leave it as 2x plus 1 times that x divided times the quantity x plus 1. Or we could write it as 2x plus 1 divided by x squared plus x. Again, either is fine. And then we would pay attention to cases where it looks like we don't have a common denominator, but we actually do. If we had 3x divided by x plus, make it x minus 5 plus 2 divided by 5 minus x. Again, we notice that 5 minus x is just going to be, that'll be the same thing as plus negative 2 divided by x minus 5. We notice we can just multiply by negative 1 divided by negative 1. And so we wind up getting 3x minus 2 divided by x minus 5. So where life gets more interesting is when we have more complicated denominators. If we had, for instance, that's a nice one, 7 divided by h plus 2, and then we subtract the quantity 2h minus 3 divided by h squared minus 4, we notice that h squared minus 4, I'll put a little line here, h squared minus 4 factors is h minus 2, h plus 2, and so we're going to need to bring in a factor of h minus 2 in that first rational expression. So we're going to get 7 times the quantity h minus 2 divided by h plus 2, h minus 2, minus the 2h minus 3 divided by same denominator. And so we notice we're going to get 7h minus 14. And now we have to be careful that 2h minus 3, we have to treat it as though it's in parentheses because of that division bar. So we're going to put that in parentheses. We subtract the quantity 2h minus 3, all divided by the quantity h plus 2, h minus 2. And so that means we're going to get 7h minus 14 minus 2h plus 3, all divided by h plus 2, h minus 2, and so we get 5h minus 11, all divided by h plus 2, h minus 2. And we actually notice if that we had started, well, once in a while we'll get something where we have to simplify, but again, it's not going to happen very often, every once in a while. So let's try something a little bit messier. If we had y divided by 4y plus 2, whoops. If we had y divided by 4y plus 2 plus 3y divided by 6y plus 3, we notice that it looks like it's a messy common denominator, but again, we want to be careful because if we factor, we get 2 times the quantity 2y plus 1. For the other denominator, we get 3 times the quantity 2y plus 1. So actually, all we need is a factor of 3 and a factor of 2. So we end up getting 3y divided by 12y plus 6, just multiplying by 3/3, plus 6y divided by 12y plus 6, just multiplying numerator and denominator by 2. And so it turns out we get 9y divided by 12y plus 6. And we actually notice that there are 2 ways we could have done this. We now notice that we have a common factor of 3. So that's going to be 3 times the quantity 3y divided by 3 times the quantity 4y plus 2. And so we end up getting 3y divided by 4y plus 2. And so we actually notice that an alternative way we could have done it is to have done the 3y divided by 12y plus... Actually, we don't even need to do it that way. We notice that we could have rewritten it as y divided by 4y plus 2 plus y divided by 2y plus 1, because we had a common factor of 3 in that second rational expression. And then we could have multiplied that second one by 2 halves and gotten y plus 2y, all divided by 4y plus 2, would have given us the same 3y divided by 4y plus 2. And so we'll often have cases where we have more than one way to get to the same final answer. And this is not unusual as you move into more complicated problems. So if we try a subtraction, let's try x divided by x squared plus 5x plus 4. And then subtract 2x divided by x squared plus 8x plus 16. We notice that's going to be the same thing as x divided by x plus 1 quantity x plus 4 minus 2x divided by the quantity x plus 4 x plus 4. And so we're going to need an extra factor of x plus 4 for the first one. The first rational expression, we get x times x plus 4 divided by x plus 1 x plus 4 quantity squared minus, we're going to need 2x times the quantity x plus 1, and then we're going to get that same denominator, the quantity x plus 1 times the quantity x plus 4 squared. And so this is one of those cases where we have to multiply everything out, combine like terms, and then check for simplification. So we're going to get x squared plus 4x minus the quantity 2x squared plus 2x, all divided by x plus 1, x plus 4 quantity squared. And so we wind up getting x squared plus 4x minus 2x squared minus 2x, all divided by x plus 1, x plus 4 quantity squared. And so we get negative x squared plus 2x, all divided by x plus 1, x plus 4 quantity squared. And so we notice that we could check it. We're going to get negative x times the quantity x minus 2. There are no common factors. But we have to check, because there could have been a common factor. So we'll try one more that's just a little bit messier. If we looked at negative 2x divided by x squared minus y squared, plus 1 divided by x plus y, minus 1 divided by x minus y, we notice that that x squared minus y squared factors as x minus y, x plus y. And so we're going to get negative 2x divided by x minus y, x plus y, plus, we're going to need a common denominator of x minus y, x plus y. So we're going to have x minus y divided by x plus y, x minus y, minus x plus y divided by x minus y, x plus y. So the first rational expression we didn't have to do anything to. The second rational expression we multiplied numerator and denominator by x minus y. Third rational expression we multiplied numerator and denominator by x plus y. And so we get negative 2x plus x minus y minus x minus y, all divided by x minus y, x plus y. Now if we combine everything, we're going to get negative 2x plus x is negative x minus x is negative 2x, minus 2y, all divided by the quantity x minus y, quantity x plus y. And now we notice we have a common factor of negative 2. We can pull out that negative 2 times the quantity x plus y, and we suddenly notice we have a common factor. And so we're going to wind up getting negative 2 divided by x minus the quantity x minus y, as long as x isn't equal to negative y. So this is a little more exotic. You're not likely to see this on an exam, but something you could very easily see if you took Math 200.